Let us see what is PERT and CPM. PERT stands for Program Evaluation and Review Technique, while CPM stands for Critical Path Method. PERT and CPM are project management tools which are used to plan the scheduling of individual activities that make up a project. PERT and CPM are used to determine the earliest or latest start and finish times for each activity in a project, the earliest and latest start and finish times for the entire project completion, and also the slack time for each activity. The critical path. Let us look at the difference between PERT and CPM. PERT and CPM are similar in their basic approach. However, they do differ in the way activity times are estimated. PERT is a probabilistic technique and allows us to find the probability of the entire project being completed by any given date. For each PERT activity, 3 times are calculated. The 3 times are optimistic, pessimistic, and most likely times. These are combined to determine the expected activity completion time and its variance. CPM, on the other hand, is called a deterministic approach. It uses 2 time estimates, the normal time and the crash time for each. Let us see how we can determine the critical path in a network. The first step is called as forward pass. So in a network, we make a forward pass as described below. For each activity I, beginning at the start node, we compute the earliest start time ES. The earliest start time ES is calculated for each activity beginning at the start node. So what is ES? ES is the maximum of the earliest finish time of all activities immediately preceding activity I. ES is the earliest time an activity can begin without violation of immediate predecessor requirements. ES is 0 for an activity with no predecessors. It is important to remember that those activities for which there are no predecessors, ES is 0. The next time we calculate is earliest finish time. Earliest finish time equals to earliest start time plus time taken to complete the activity I, or duration of activity I. Earliest finish time represents the earliest time at which an activity can end or can be finished. What is the project completion time? The project completion time is the maximum of the earliest finish times at the finish node. So the project completion time is the maximum of all the earliest finish times at the end node of the network. Now, the second step in determining the critical path is called as backward pass. So we make a backward pass through the network as follows. We move sequentially backward from the end or finish node to the start node. At any given node J, we consider all activities which are ending at node J. For each of these activities Ij, we compute first the latest start time. Latest start time equals to latest finish time minus time taken to complete the activity Ij. Latest start time is the latest time an activity can begin without delaying the entire project. Then we calculate latest finish time, or LF. LF is the minimum of the latest start times beginning at node J. For the end node, this is the project completion time. Now, it is important to remember that the latest finish time LF for the last node is the same as EF of the last or end node. This is the latest time an activity can end without delaying the entire project. The step 3 in determining the critical path is calculating total float. Total float, also called as slack, equals to latest start time minus earliest start time or latest finish time minus earliest finish time. A critical path is a path of activities from the start node to the finish node with zero slack time. So all the activities which have zero slack or float time are critical activities of the network. Let us see how we can determine the critical path in a network. The first step is called as forward pass. So in a network, we make a forward pass as described below. For each activity I, beginning at the start node, we compute the earliest start time ES. The earliest start time ES is calculated for each activity beginning at the start node. So what is ES? ES is the maximum of the earliest finish time of all activities immediately preceding activity I. ES is the earliest time an activity can begin without violation of immediate predecessor requirements. ES is 0 for an activity with no predecessors. It is important to remember that those activities for which there are no predecessors, ES is 0. The next time we calculate is earliest finish time. Earliest finish time equals to earliest start time plus time taken to complete the activity I or duration of activity I. Earliest finish time represents the earliest time at which an activity can end or can be finished. What is the project completion time? The project completion time is the maximum of the earliest finish times at the finish node. So the project completion time is the maximum of all the earliest finish times at the end node of the network. Now, the second step in determining the critical path is called as backward pass. So we make a backward pass through the network as follows. We move sequentially backward from the end or finish node to the start node. At any given node J, we consider all activities which are ending at node J. For each of these activities Ij, we compute first the latest start time. Latest start time equals to latest finish time minus time taken to complete the activity Ij. Latest start time is the latest time an activity can begin without delaying the entire project. Then we calculate latest finish time or LF. LF is the minimum of the latest start times beginning at node J. For the end node, this is the project completion time. Now, it is important to remember that the latest finish time LF for the last node is the same as EF of the last or end node. This is the latest time an activity can end without delaying the entire project. The step 3 in determining the critical path is calculating total float. Total float, also called as slack, equals to latest start time minus earliest start time or latest finish time minus earliest finish time. A critical path is a path of activities from the start node to the finish node with zero slack time. So all the activities which have zero slack or float time are critical activities of the network. So let us see an example problem. Here on the table on the left side, you can see activities are given 1 to 2, 1 to 3, 2 to 4, 3 to 4, 3 to 5, 4 to 9, and so on till 9 to 10. And we have days or duration it will take to complete these activities. Let us first start to draw network diagram for this project. So we have first node, which is the beginning of the project. Now we see here that activity, first activity is 1 to 2. So this is the first activity 1 to 2. The second activity is 1 to 3. So we draw an arrow representing the second activity 1 to 3. The third activity is 2 to 4. So we draw an arrow representing the activity 2 to 4. And also the fourth activity is 3 to 4. So both activities have the same end node, that is 4. Therefore, both activities merge at the event node 4. We have seen in earlier videos how to draw network diagram. We know that each circle represents an event. Each circle is called as an event. The activity is represented on the arrow. So for every activity, there is tail event called as the beginning event or start event, which represents the start of that activity, whereas there is head node, which represents the end or finish of that activity. Now let us draw other activities of the network. So we have activity 3 to 5, and then activity 4 to 9, and then activity 5 to 6, 5 to 7, 6 to 8, and 7 to 8. Now these activities merge at the common node 8. Then we have 8 to 10 and 9 to 10. So we have drawn the project network here. Now let us put the duration of each activity on the network. So duration for activity 1 to 2 is 4 days. Duration for activity 1 to 3 is 1 day. Duration for activity 2 to 4 is 1 day. Duration for activity 3 to 4 is 1 day. Duration for activity 3 to 5 is 6 days. Duration for 4 to 9 activity is 5 days. Duration for 5 to 6 activities is 4 days. Duration for 5 to 7 activities is 8 days. Duration for 6 to 8 activities 1 day. Duration for 7 to 8 activities 2 days. Duration for 8 to 10 activities 5 days. And duration for 9 to 10 activities 7 days. So here we have the complete network diagram for the project. Now let us move to the next step. Once we have drawn the network diagram, the next step is to do the forward pass. What is forward pass? In forward pass, we calculate early start at each event or each node. Forward pass moves from left to right. That is, in forward pass, we do calculations from the starting node to the end node. While doing forward pass, early start time of the first node or the starting node is always taken as 0. In this network, the first node of the network or the beginning node or the beginning event is event 1. Therefore, early start of event 1 ES1 is 0. Now we proceed to calculate early start event of event 2. So early start of event 2 would be early start of the previous node. So which is the previous node here? It is node 1 plus the duration of the event, which is 4. So early start of event 2 is ES1 plus 4, that is 0 plus 4 equals to 4. Similarly, early start of event 3 is ES1 plus 1 equals to 0 plus 1 equals to 1. Early start of event 4 equals to 4 plus 1 equals to 5. Now, early start of event 4, there are two activities merging at event 4. Those two activities are 2 to 4 and 3 to 4. Now we will calculate early start using both the activities. So if you take activity 2 to 4, early start is 4 plus 1, 5. If we take activity 3 to 4, early start is 1 plus 1 equals to 2. So of these two early starts, we take the early start which is maximum. So maximum early start here is 5. Therefore, we have taken 5 as the early start at event 4. The next event is event 5. Early start at event 5 equals to early start of event 3 plus duration of the event 6. So we have 1 plus 6 equals to 7. Early start of event 6 equals to early start of event 5 plus duration of the event. So we have 7 plus 4 equals to 11. Early start of event 7 equals to early start of event 5 plus 8. So 7 plus 8, 15. Now early start of event 8, again at event 8, two activities are merging. These two activities are 7 to 8 and 6 to 8. So we calculate early start using both the activities. So for 7 to 8 activity, early start is 15 plus 2, 17. For 6 to 8 activity, early start is 11 plus 1, 12. Of these, 17 is maximum. Therefore, ES8 equals to 17. Now, early start at node 9 equals to early start of node 4, which is 5, plus duration of the event 5, that is equal to 10. Early start at node 10, again at node 10, two activities are merging. They are activities 9 to 10 and 8 to 5. Therefore, we calculate early start using both the activities. Now, if we take activity 9 to 10, early start would be 10 plus 7, 17. And if you take activity 8 to 10, early start would be 17 plus 5, 22. Of these, 22 is maximum. Therefore, we have taken 22 as the early start of node 10. Now, once we have calculated early starts at all the nodes, we begin backward pass. Backward pass is done from right to left. That is, we move from the end or finish node to the start node. So we begin at the end event or end node and we move towards the start node. In backward pass, we calculate latest finish of an event. So latest finish of the last node is the same as the early start of the last node. Okay, therefore latest finish of the 10th node, which is the last node of the network, is same as the early start at that node, that is 22. Now let us calculate latest finish at node 9. So how do we do that? We take latest finish of the last node, that is the 10th node, and we subtract the duration of the activity from it. So 22 minus 7 equals to 15. Now latest finish at 8th node is latest finish at 10th node minus duration 5. So 22 minus 5 equals to 17. Latest finish at 7th node equals to 17 minus 2 equals to 15. Latest finish at 6th node equals to 17 minus 1 equals to 16. Latest finish at 5th node equals to, now at 5th node we have two events emerging. In that case, we take minimum of the latest finish of the two activities. So we are going to calculate latest finish using both the activities and we are going to take the minimum of them. So for the first activity, latest finish is 16 minus 4. For activity 5 to 6, which is 12. And for 5 to 7 activity, latest finish equals to 15 minus 8 equals to 7. So 7 is the minimum, therefore we have taken 7 as the latest finish. Now for node 4, latest finish equals to 15 minus 5 equals to 10. For node 3, latest finish equals to, again at node 3, two activities are emerging. They are 3 to 4 and 3 to 5. So we calculate latest finish using both the activities. For activity 3 to 4, latest finish equals to 10 minus 1, and for activity 3 to 5, latest finish equals to 7 minus 6. So the minimum is 1 and therefore latest finish for node 3 equals to 1. Now latest finish of node 2 equals to 10 minus 1, that is 9, and latest finish of node 1, again at node 1 two events are emerging. Those two events are 1 to 2 and 1 to 3. For 1 to 2 event, the latest finish calculated is 9 minus 4, and for 1 to 3 event the latest finish calculated is 1 minus 1. So the minimum is 0 and therefore latest finish at node 1 is 0. Now we put all these values of early start and latest finish in a table which you can see on the right hand side. Now let us go to the next step. In the next step, we are going to find the critical path of the network. Now you can see on the top left hand corner of the screen, you can see the network diagram, and we are going to plot out all possible paths in this network. So all possible paths in this network you can see below. The first path is 1, 2, 2, 2, 2, 4, 4 to 9 and 9 to 10. Okay, this is the first possible path in the network. Now duration of 1 to 2 activity is 4, 2 to 4 is 1, 4 to 9 is 5 and 9 to 10 is 7. You add up all these activities duration and the total duration of this path is 17. The second possible path in this network is 1, 2, 3, 3 to 4, 4 to 9, 9 to 10. This is the second possible path. Now duration of activity 1 to 3 is 3. Duration of 3 to 4 activity is 1. Duration of 4 to 9 activity is 5. Duration of 9 to 10 activity is 7, which totals up to 16. So total duration of the second path is 16. The third possible path is 1, 2, 3, 3 to 5, 5 to 7, 7 to 8, 8 to 10. This is the third possible path. The individual duration of the activities are 1, 6, 8, 2 and 5. So total duration of this path is 22. Now the fourth possible path is 1, 2, 3, 3 to 5, 5 to 6, 6 to 8 and 8 to 10. The individual durations are 1, 6, 4, 1 and 5. The individual durations of the activities add up to total duration equals to 17. So in this network, there are 4 possible paths in the entire network, of which the third path has the maximum duration of 22. Therefore, the third path is taken as the critical path. The third path is taken as the critical path because the total duration of this path is the maximum. Okay. Now let us go to the next step. We have calculated the early start times or ES at each node using forward pass, and we have calculated the late finish times or LF at each node using backward pass. We are now going to do some more calculations. Here we have all the activities of the project. The duration of each activity of a project is given in T, and we now calculate early start time or ES for each activity. Take activity 1 to 2. The first node of activity 1 to 2 is 1. ES1 is 0. Therefore, ES of activity 1 to 2 is 0. For activity 1 to 3, the beginning node is 1. ES1 is 0. Therefore, ES for activity 1 to 3 is 0. For activity 2 to 4, first node is 2. ES2 is 4. Therefore, ES for activity 2 to 4 is 4. For activity 3 to 4, the beginning node is 3. ES3 is 1. Therefore, ES for activity 3 to 4 is 1. And similarly, we calculate ES for all the activities. We then calculate early finish time or EF for all the activities. The formula to calculate early finish time or EF is ES plus T. So for activity 1 to 2, ES is 0, T is 4. Therefore, EF is 4 plus 0 equals to 4. For activity 1 to 3, ES is 0, T is 1. So EF is 1 plus 0 equals to 1. In this manner, we calculate EF for all the activities of the project. We then calculate latest finish time or LF for all the activities. For activity 1 to 2, the end node is 2. Now, latest finish time for node 2 is LF2, which is 9. Therefore, LF for activity 1 to 2 is 9. For activity 1 to 3, the end node is 3. LF3 is 1. So LF for 1 to 3 activity is 1. For activity 2 to 4, latest finish, the time is 10. The end node of activity 2 to 4 is 4. LF4 is 10. Therefore, LF for activity 2 to 4 is 10. For activity 3 to 4, the end node is 4. For end node 4, LF4 is 10. Therefore, latest finish time for activity 3 to 4 is 10. For activity 3 to 5, the end node is 5. LF5 is 7. Therefore, LF for activity 3 to 5 is 7. In the same way, you calculate LF for all the activities. We then calculate latest start time for all the activities. The formula to calculate latest start time or LS is LF minus T. For activity 1 to 2, LF is 9, T is 4, so LS is 9 minus 4 equals to 5. For activity 1 to 3, LF is 1, LS is T is 1, so LS is 1 minus 1 equals to 0. For activity 2 to 4, LF is 10, T is 1, so LS is 10 minus 1 equals to 9. And in the same way, you calculate LS for all other activities. We now calculate total float of all the activities. The formula to find total float is LS minus ES or LF minus EF. So for activity 1 to 2, LS is 5 and ES is 0. Therefore, total float is 5 minus 0 equals to 5. For activity 1 to 3, LS is 0 and ES is also 0. So total float is 0 minus 0 equals to 5. For activity 2 to 4, LS is 9 and ES is 4. So total float is 9 minus 4 equals to 5. In the same manner, you calculate total float for all other activities. We then find out the activities for which total float is 0. These activities for which total float are 0 are called as critical activities. These activities are 1 to 2, 1 to 3, 3 to 5, 5 to 7, 7 to 8 and 8 to 10. Now we have earlier seen critical path and we can reconfirm the critical activities from the problem solved earlier. I hope you understood how to find the critical path in a network. Thank you.